Hello guys! Today's video is about the Moivre's theorem, and we are going to use this theorem to get complex roots of a number. In previous videos we studied the polar form, but today we need to remember a little bit the formulas that we are going to use to represent a complex number in polar form. So, we have to know R, that is the norm of the complex number, theta, that is the angle formed from the real axis to the vector formed by the complex number, and finally, Z, represented as the polar form. Another way of representing the polar form of a complex number is using the Euler's formula. This one provides a means of conversion between Cartesian coordinates and polar coordinates. And, well, the polar form simplifies the mathematics when used in multiplication or powers of complex numbers. And today we are going to study the power of complex numbers. The Moivre's theorem states that for any complex number as given, the following statement is true, where n is an integer. We can also represent this by the Euler formula, and this is the Moivre's theorem. We are going to use these equations to solve a problem. Compute the complex roots of z when z cubic minus 1 is equal to 0. We are going to use the formula from the Moivre's theorem, and the first step is to clear z. And z is equal to the cube root of 1. And using the powered identities, we can also represent it like this. The next step is to represent the complex number 1 in its polar form. We are going to use these equations for the polar form. In this case, r is equal to 1 and theta is equal to 0. We substitute these values, and this equation can be represented as a general form by adding 2 pi times a that represent a times a whole circle. Remember that one circle has 2 pi radians, and a is any natural number. Now we are looking for the 3 complex roots of z, so we have to power both sides of the equation by 1/3. In this point of the problem, we use the equation from the Moivre's theorem for a equal to 0, 1, and 2. For the first root, we substitute a equal to 0 in the equation, compute these values, and the first root is equal to 1. For the second root, we substitute a equal to 1, and the same for the third root. These are the 3 roots for this problem, and we can also represent these roots in the complex plane, as you can see. In this problem, we want to compute 2 roots of this complex number, and we are gonna use the polar form using the Euler's formula. The first step is to define z, our number or complex number z, and to represent this number in its polar form, we need to know the angle theta and also the norm r. So we are computing these values. And now we can substitute these 2 values in the formula. And this is the representation of our complex number in polar form. The next step is to add the power to the both sides of this equation. And the problem is asking us for two roots. So k is equal to 0 and 1. For the first root, k is equal to 0, we only have to substitute this k in the formula, and also for the second root, we substitute k equal to 1. And these are our two roots for this problem. In today's video, we studied the polar form. This first equation we already studied in our first video about complex numbers. So if you have any question about this polar form, you should watch our first video about complex numbers. And we also learned a new type of polar form by using the Euler equation. And we used this polar form to compute the complex roots of a complex number by using the Moivre's theorem. So I hope this video was useful for you. I hope to see you in other videos and subscribe to our channel. Bye!
Thanks for watching our math videos. We love helping you learn. Please be sure to subscribe and check out our other topics.